All right, so we have some requirements for assigning probabilities. Basically, the number that we assign has to be between 0 and 1. So can't have any negative probabilities and can't have anything greater than 1. When we do take all the probabilities together that we've assigned for all the different potential outcomes, then it's got to add up to 1. So something happens. So with that, though, there are different ways about which we can go and assign the probabilities. And so if we're thinking about assigning these probabilities, there are basically 3 different methods that we're going to consider here. And those are the classical method, basically assuming that everything is equally likely. So sometimes that's reasonable, sometimes not. So if thinking about throwing or rolling a die, and what's the probability that it comes up a 1 versus a 2 or 3, all the outcomes are equally likely. At least it's a fair dice, seems reasonable. Another method is the relative frequency method. So we can think about empirical probabilities. And here we're just looking back at historical data. So we're doing something like constructing a relative frequency table we've seen before, and using that to evaluate or approximate, estimate, however you want to think of it, the probabilities that we're assigning. So that's the relative frequency method. And then there's the subjective method. So simply assigning the probabilities based on judgment. So to go over each one of these in a little bit more detail, let me just go to the classical method first. So in that case, you might think of a situation where you've got something like a roulette wheel, or I mentioned before, dice or a deck of cards. And on a roulette wheel, all of the slots are equally likely. There are 38 slots, and 2 of them are green. That's the 0, and there's a double 0. So if we're thinking about the classical method, where each slot is equally likely, then the probability of landing on green is 2 out of 38, or about 0.05263, right, since all slots are equally likely. So then if we think about the empirical method, we're thinking about getting a relative frequency. What we would typically do is construct a relative frequency table, as we've seen before. It might show consumer preferences. In this example, soft drinks, it's one I've shared before. And then we might look at it and see the relative frequency of Dr. Pepper coming up as the preferred soft drink maybe is 0.067. So then how do we interpret that? That means that the probability of a consumer preferring Dr. Pepper is 0.067. This could be for things other than soft drinks, of course, or whatever outcome it is that we're looking at in any particular experiment. The last method that we mentioned is the subjective method. So let's consider a scenario where we don't have data to look at. So we don't have past history with this, and we can't use those. So we have to come up with some other method, and that is this, the subjective method. So an example where this might happen is a company is trying to work out a deal with a new business partner where they haven't done business before. And so in that scenario, one executive or one official with the company, so one vice president, might believe that the probability of the deal going through is 0.7, and another vice president believes that the probability is 0.4. We don't have any data to look at to assess whether or not one of these is actually, in some sense, more accurate or a better assignment of probability than the other. Just going on the judgment of these 2 different vice presidents. So with that, then, think about events and their probabilities. An event is a collection of sample points. So here's just definition. And the probability of an event is equal to the sum of the probabilities of the sample points in the event. So think about an example we've seen already. Think about the green on the roulette wheel. So the sample points would be that if the ball lands on 0 or the ball lands on double 0. Those are 2 different sample points. They come together to be the event of green. So the probability of any event, again, is equal to the sum of these probabilities. So in that case, we had, instead of 1 over 38 plus 1 over 38, it's 2 over 38 in that example. So if we can identify all the sample points, that then we can assign a probability to each of them, and we can compute the probability of an event that's comprised of multiple sample points potentially. So example within economics would be something like the Bureau of Labor Statistics calculating the monthly unemployment rates. So in that case, there is something that could take place, an event, which is that the person is not in the labor force, but that can take place in different ways. The person could be not in the labor force because they're going to school, or because they're retired, because they're a full-time caregiver. Those are just some examples. So we would have those different sample points make up an event that's not in the labor force. Okay, I want to think about then the complement of an event. So the complement of an event is defined to be the event consisting of all sample points that are not in event A, let's say. So the complement is denoted with a little c for the superscript there. And we'll just go back to the rule that probabilities have to sum to 1. So the probability that something is in A or its complement is going to equal to 1, is what we've got there.